Okay. So that's recording, and you guys are welcome to ask questions. That's fine. Let's not mention anybody's names as this goes on YouTube. Okay. I don't think that's a problem, but let's keep that. Let's keep that in mind. Okay. So I was talking about the way the course will work moving forward is I'll come in, we'll have a topic or two that we'll talk about between now and the midterm. The earliest the midterm's going to be would be October 8th, okay? Probably a little bit after that. What I'm going to try to do, so if we look at the calendar here. All right, so we're in September, so at most 2 weeks from today would be the midterm. I'm going to reach out to some former students of mine and some other engineers that I know out in the field and see if I can line up a guest speaker or two over the next couple of weeks or so. That will kind of change, depending on how that lines up, that may change where I put the midterm. If I've got people that can be here next week or the week after, if I've got people that can be here the 29th, 1st, 6th, or 8th, then that'll kind of push the midterm back just a little bit whenever I get somebody lined up. I try to get at least one, if not two guest speakers lined up. Given the pandemic and everything else, let me see what we can do. Okay, I got to try to work with those individuals, and I don't know, I don't know how palatable it is to get somebody to come to campus, right? We'll see, and maybe we bring them in on a Zoom call. I don't know. We'll figure something out. Okay. So kind of work with me on that, but again, the earliest I would do the midterm would be the 8th, and it would move back depending on what the rest of the schedule comes out in the next couple of weeks. There's just a couple more topics that we'll add to and talk about that will be on the midterm, and no matter what the class period before the midterm, we'll have a day where we'll review, talk about all the topics that are going to show up on the midterm. They're there in the Canvas module, so you have access to what we're going to talk about, or at least, and I'll make an actual list and put in the Canvas. There's not a concise list, but all the materials for the midterm is in the Canvas modules. There's no textbook for the course. Okay, so again, class period immediately before the midterm, we'll take a day, review, make sure everybody's comfortable with how we're going to do the midterm, and go from there. Okay. So whether that's the 6th or whether that's later, give me a day or two to kind of figure that out. Okay. Let's see what else. So as I mentioned, there's a couple of topics we'll hit on that achieve some learning outcomes and make sure that we get those on the midterm and test for those. So questions so far?
Will the midterm be in class, like new class period?
Yes, most likely.
Okay.
I did the midterm online in the spring, and it was pretty effective, but that was not by choice, right? We had to do that. It actually worked out, I think, pretty well, so I let me look at it and see. I may put it on the computer since we've been working on the computers here lately, and there's some advantages to that. I don't know for sure. Let me make sure. And my gut feel is, we can do it either way.
Yeah.
Yeah. Other questions? Okay. So one of the topics that shows up on the midterm that we want to talk about today, there's two topics here actually. One of them is about PE licensure, and the other one is about coursework, fundamental engineering coursework that shows up in most engineering curriculum, and those two go together, and we'll talk about why in just a little bit here. Okay, now what is a PE? What is PE licensure? Well, there's actually a license for people in the engineering field. There's what we call a PE. Those are similar to, say, like a CPA or an MD. That's a credential that you can earn, that if you are a PE, you can, when you sign your name, you can put those letters at the end of your name, just like PhD or CPA or something like that. That is an individual that is recognized by a government or state entity as competent and professional in the field and art of engineering. Okay? That is, I am not a licensed PE myself. I'm just, I could go through the last couple of steps in the process. It doesn't change what I do here, and I don't have a lot of interest in the type of work that would be readily available, that would be easy for me to do part-time. It's not something that I've needed or is interesting to me at this point. So not being a licensed professional engineer, I can't legally offer my services to the public. I can't go post a Craigslist ad and say engineer for hire. I'm not legally recognized as an engineer. Now, that doesn't mean I can't go out and get gainful employment without a PE. There's lots of job opportunities for people with an engineering degree that don't have that PE licensure. Most of your other fields, though, that were, say like an MD, a medical doctor, you could go to med school and not pass the board exams and the examination process or never take those exams. Just go to med school and get that knowledge and not actually be an MD. That's possible. Same thing with a CPA or an attorney. People can go to law school and not ever take or pass the bar exam. There's still some opportunity for employment, but not as much probably in those fields. With engineers, it's a little different. There's plenty of employment for engineers with the degree, but aren't licensed, and we can talk about the reason for that. It's going to be one of kind of the main things today. Is again, a PE means that you can work in the public domain as an engineer. Okay. So if I'm looking at something like civil engineering or structural engineering, environmental engineering, these are all areas that's kind of a goal that people in these fields are always going to be working towards. It should always be on their radars, is working towards that professional engineering license. Because these are individuals that are always going to be working with the public, or a lot of times they're going to be working with the public. The projects that they're going to be working on are a lot of times funded with taxpayer dollars. For me, that's kind of a good measure of does this need a PE or not? Well, are taxpayer dollars involved? It's not perfect, but it's not a bad litmus test. So these types of engineers definitely fall into that category. Some parts of mechanical and electrical engineering and some others will fall into this category, but it's not always a requirement to be successful in those fields. So public work must be approved by a PE. That doesn't mean that PE is actually doing that work. It just means that PE has looked at and has signed off and approved that this makes sense, this will work. To give you an example, all right, this can be really mundane stuff. My wife and I live off of a state highway. Right? We live kind of out in the country, live off a state highway, and when we've had our house put in, because our driveway connects right to a state highway, a licensed engineer had to sign off on the documents submitted to ODOT for the installation of this driveway. And basically it amounts to, yes, water runs downhill. That's oversimplifying. As a taxpayer, right, I want to know that I can appreciate that somebody looked at the design of that driveway, just gravel and a pipe, but somebody looked at it and said, well, given a 100-year event storm and the slope of the ground in this location, this pipe will be big enough to accommodate most flooding issues, and it's not going to cause flood on that road that my taxpayer dollars pays for, right, and your taxpayer dollars pay for. So that's just kind of that's a very simple, mundane example I can give of something that, and I guarantee you the PE that stamped and signed off that the design of my driveway was okay. I guarantee it was not the PE that stamped it that actually drew up the drawings and figured out how big of a pipe needed to go in there. That's just the individual that looked at it, checked everything, and said, yes, this will be just fine. Okay, most likely. What will typically happen for a licensed PE is they're simply the ones that are looking over the documentation, checking any numbers, or they're the people that actually put together those documents and run the numbers are working directly for that licensed PE. And so the PE has been involved in that process throughout and is comfortable those numbers are correct. Okay. Yes, ma'am.
If I may add to that, if you, and just based on my experience
Sure,
in
absolutely.
the field, if you want to go into business for yourself and you want to establish a company that renders engineering services to bigger entities, right? You have to have a PE on staff.
Yes.
And as a business owner, your PE will always be probably your highest paid. And the Secretary of State will make sure that you have somebody on staff that's a PE. Otherwise, they will not let you call your company an engineering firm. You have to be, you know, for just as an example, Central Resources as opposed to Central Engineering. My husband and I have looked into, and this is coming from about 15 years of experience in oil and gas prior to saying, hey, you know, I want to be an engineer. We want to clean the lines, like the pipelines, right? There's thousands and thousands of miles of gas pipelines in the country. Well, we can do it. We know how to do the work. We know how to get the equipment. You can lease the equipment. You don't even have to have more than like $25,000 worth of revenue to start a company like that. But if we want to be taken seriously, and it pays a lot, we have to have a PE on staff. So we can either save up another $120,000 to have a PE on staff, or I can become a PE and we can save ourselves that kind of money. So anyway, keep that in mind.
Very much in the vein of what we're talking about today is, yes, to offer, as I mentioned, to offer services of your company to the public to go after large-scale, public-funded contracts. You have to have a PE on staff. And again, it doesn't necessarily have to be the PE doing the work.
Right.
It's just the PE is the one that has the final say or looks at and says that yes, all the calculations check out. You're not violating any laws of physics. This should all work. Okay. So now, if you go to work for a manufacturing firm, the business school a lot of times will use the term widgets. Right. That's just a generic term for something that we're going to produce or manufacture. So if I go to work for a company producing some type of widget, there's a good chance I don't necessarily need a PE to do that kind of work. Okay, there's most likely not anything that company is going to be doing in a manufacturing area that would require public funding. Okay, if they do, you know, then maybe a PE is relevant there. So a lot of times a private company, a manufacturing firm, which is where a lot of engineering work is going to go into, is not going to have a lot of preference as to whether you've got a PE or not as the engineering employee. In fact, they probably aren't, you hope they don't discourage you from it, because that does mean you could do contract PE work on the side. You could work for a company that needs a PE part-time or on staff. So it does allow you other avenues to spend your time. And so a private company may or may not necessarily need, if they don't need you to be a PE, they're not going to have a lot of preference as to whether you are or not. Okay. Now, as mentioned, any kind of public engineering work must be approved by a PE. Did I go back? Yes, I went backwards, sorry. Hit the wrong button. Okay. So, a couple of things to consider here. Who gets to decide who is a PE? In the United States, PEs are granted by the individual state. Each individual state decides who can practice within their state as a licensed professional engineer. Okay? So each state can, in theory, set up their own requirements. Most of them don't. Most of them are pretty similar, if not the same. However, that is at the state's discretion as to who they recognize as a licensed professional engineer. What happens then is, if we're talking about manufacturing widgets and we want to sell widgets outside of our state, does that mean we have to be signed off as a PE? No, there's what we call the industrial exemption. Most manufactured goods do not require to be sold across state lines, because imagine if because every state has its own requirements for who can be a PE, and then this state says this widget has to be signed off by a PE in the state it's manufactured in, as well as a PE in the state that you're selling it to. And it just, no, in a capitalist society, that's just not going to work. So we allow people to sue each other if you do something wrong, right? And that's our solution. And that, it has its advantages. So the industrial exemption is granted to most manufactured goods, to where you don't necessarily need a PE to sign off on that. And that's why I'm telling you, in many areas, there's a lot of work available for somebody in the engineering area with an engineering degree that doesn't require PE. There's a lot of work that does. And it just kind of depends on which area you go into. The good news is you don't have to worry about that for the next several years. Okay? So it's going to be several years down the line as to whether you can make that decision later. But there are some things that we're going to talk about that you can do now working towards it. Okay? So, again, PEs are granted by the individual states. Yes, you can sell goods between states, but offering services as a consultant, offering services as an engineer, you do have to have a PE to do that. Most states tend to play well with the states that border them in terms of PEs. So, again, I'm not a licensed PE, but let's say I was a licensed PE in the state of Oklahoma. And if a friend of mine in the state of Kansas says, hey, we need a PE to sign off on our documentation, we're going after this contract, can we hire you part-time to stamp these documents? Not immediately. I'm not licensed in the state of Kansas, so I can't do that immediately. What I can do is I can apply to the Kansas Board of Engineers, whatever that entity is called, and request either temporary licensure or just recognition of my credentials. I can say, look, I'm licensed in this state. Here's my credentials. Here's my background. Can I get temporary access to practice within your state? And a lot of times the bordering states, as I mentioned, will play well with others. If I'm licensed in Oklahoma and somebody in Hawaii needs my services, I'm gonna bet they're gonna want somebody local to look at that, because their requirements and their environmental concerns are going to be different than ours. Okay, so that's completely at the state's discretion, as it should be, as to who can practice engineering in their state. Okay, so how does one become a PE? Now, the process is very similar. I'm going to write this one down because this one's one of the biggest takeaways here. Becoming a PE. Bless you. Make sure I'm on the screen. Yes, I appear to be on the screen. Okay. Becoming a PE. Step 1 is what we call the FE exam. You take an individual must pass this grueling fundamentals of engineering exam. Today it's done on the computer, and you get access to it, and it's done at a facility. I don't know how they're doing it right now in the pandemic. I'm not asked. I don't want to know. Step 1 is you take and pass the FE exam. This is an exam that tests you over your knowledge of basic engineering subjects that you would have learned about in school. You're eligible to take the exam when you complete 90 credit hours or more in an accredited engineering program. Okay, so that's basically your first senior year, right? Because most of us are going to have multiple senior years. It's very rare you finish an engineering degree in 4 years. So normally it's like your first senior year, you're eligible to take the exam. Okay, now you had to look at the subject matter and look at what courses you've actually completed at that point to see if you're actually ready. And that's a discussion that you can have at your university when you get there. Okay, that's step 1, and then step 2, and these two go together, right? Or at least they should. That is finishing a bachelor's degree. Now, there's what we call ABAT accreditation, or ABAT accredited. okay? Now, this is the Accrediting Board for Engineering and Technology. That's an international organization where individuals go around, they look at engineering programs and technology programs, computer science programs, and they certify that they're meeting very high standards. And the idea there is that an engineering degree is an engineering degree is an engineering degree. If it's ABET accredited, a mechanical engineering degree at OSU as opposed to OU, as opposed to University of Texas, as opposed to MIT, if they're ABET accredited, they've met a very high standard, and that's one of many reasons engineers are very employable, is because all engineering programs are meeting this very high standard of of achievement and rigor and coursework. So again, it's an accrediting body that comes through, looks at programs, makes sure they're all doing very similar things, if not the same, all of the programs, well, I can't say all, but many programs in Oklahoma, both, to my knowledge, both at Oklahoma State and the University of Oklahoma, those programs are all ABET accredited. I believe now all the programs at UCO are ABET accredited. There are some other places in the state also. I think Tulsa and Oral Roberts also have some ABET accredited programs. Oklahoma Christian University, some of their programs are ABET accredited. You have to look, right? You have to look, and they'll be very proud of that. If you go to their website, they're going to have that published. They should, okay? It's going to be very obvious that that's an ABET accredited program if you just do a little bit of research. There are ways to get around it if you get a degree from a non-ABET accredited school. You can normally continue working towards a PE. There's just going to be a lot more hoops you're going to have to jump through. And at the state's discretion, they could say no. But if you've got an ABET accredited bachelor's degree, that's kind of a nice, simple thing that you should be working towards at this point. There is discussion, I've heard for years now, there's discussion about wanting to move towards maybe not a complete master's degree, but some graduate level work towards a PE. To my knowledge, no state has implemented that. There's been some that have been close, but there is a lot of discussion. That's kind of, I've heard for the last decade, but that's kind of the future, that they're heading that direction, at least some graduate level work. We're not there yet, but so just kind of something to be aware of.
Why do you think? Do you think we just have too many students doing well with the program and it's flooding the market, or?
No, I think it's the problems we solve are becoming ever more complex.
Oh, okay.
That's
Well,
my
that's
philosophy. I could be wrong.
Good to know.
So it's typically in most states it's a 4-step process. Okay, first two, these are basically kind of in your these should be kind of in your 5-year plan for most of us in this room, right? Maybe faster, but this is kind of in your 5-year plan. Now the good news about when you pass the FE exam, once that's done, I passed mine, goodness, going on 20 years ago, right? Early 2000s is when I passed mine. I never have to take it again. I could go tomorrow and apply to the state board and say I'd like to become a licensed PE. Here's my FE credential. That's done, right? So what I'm telling you is get this done while you're in school, because there's no reason not to. I mean, you do have to pay an examination fee, but that's probably going to increase as time goes on. So get it done now while it's the price that it's at, and that never goes away, right? And then once you've got a bachelor's degree in hand, that never goes away. So these are things that you can accomplish now and work towards, and these other things are going to come later in your career when you've got a better idea whether you're in an area that you need a PE, or you're working for a manufacturing firm or an aerospace firm that maybe doesn't need a PE, or you don't have to be the PE. You can make that decision later, but go ahead and make this decision now, whether you go this route or not. Right? That's kind of what you want to work towards. So step 3, I'm just going to put in quotations the word experience. Right? Because this is one place where the states, at their discretion, are going to have some control as to who they allow to be recognized as an engineer or not. In many, kind of in the traditional setting, you would have EITs, is what's somebody that passes the FE exam is called an EIT. That's engineering and training, or an engineering intern. And that's what I am. I'm an EIT. Okay. The traditional model would be you've got a licensed PE, and you've got multiple EITs working under that licensed PE, gaining experience, learning the field of engineering and what it means to be a practicing professional engineer. That's the traditional model. Not everybody, that doesn't work for everybody. You've got a lot of people that are competent in the area of engineering that don't necessarily work under a licensed professional engineer. My supervisor, my dean, he's also an engineer. He's an industrial engineer, but he's not a licensed PE. But as I read the regulations in our state, there is an appeal process where I could appeal to the state board and say, I believe I'm competent in the area of engineering because I've been teaching engineering classes for 13 years, right? So that's, and that's, from what I understand, and that's typically going to be looked upon favorably by the state board. But it's kind of up to the state board as to what they consider relevant experience. The baseline typically is they want at least 4 years removed from school, 4 years removed from your bachelor's degree. That's most states. Some states it's more. I don't believe any states are less. And then, you know, if you've not just been working, if you don't fit the traditional mold of working for 4 years under a licensed PE, and they're going to write you a letter of recommendation, you've got some other PEs you know are going to write you a letter of recommendation. If you don't fit that traditional mold, then you just have to appeal to that state board and convince them that you're competent in the area of engineering. And then the last step is what's called the PE exam. And this is a multi-hour, I believe right now it's about 8 hours. And that it is, those long exams are as bad as they sound. There's what we call the Principles of Practicing Engineering exam, the PE exam. It's a standardized exam. It's the same exam given nationally, right? So again, what's the variation from state to state? It's here. It's number 3. What does that state consider appropriate experience for their state? The FE exam is the same nationally. The PE exam is the same nationally. ABET accreditation is a standardization nationally, internationally. Right? So there's not a lot of variation, but there is, again, at the state's discretion, they have some variation. Okay. Questions, Hugh, so far?
Are there practice exams?
You can find them. I'd have to go back and look. To my knowledge, I don't think the licensing or the national organization that puts together these exams, I don't think they publish practice exams, but you can find them through third-party vendors that some people will sell, and that some of those are really good. You'd have to.
And so there's the FE exam, right? And then you go through another 3-4 years of experience. I mean, how do you keep that knowledge fresh, right?
Sure. No, and that's a very good question. The knowledge is different. It's been a while since I've looked at practice PE problems, but these are different problems, where these are going to be like textbook problems, similar to the problems that you're going to see in your physics classes, your dynamics classes, your thermodynamics classes, where these are a lot more applied to like a real world scenario where they give you multiple inputs, lots of information. You have to sort through what's the relevant information, what are the laws necessary to solve this, and it's more of it's a larger problem a lot of times. And you have more access to resources on the P exam than you do the FE exam.
So is that a case where don't feel like a failure if you fail it like the first 2 or 3 times?
Yes. Yes.
Okay.
Absolutely. To that point, though, I do know people that said, they looked at this FE exam and said, I'm not going to do that in school, and then later in life they get in a position where they need that PE. They realize that the career path they've chosen, the PE would be beneficial to them, and so they've got to go back after they've been out of school for years and go back and relearn the FE exam. That's what I'm telling you guys is do this now, right? You're working towards this. Go ahead and get this done when you're ready for it, right? Before you leave school or shortly after you leave school. Sometimes some university programs will reimburse you if you pass the FE exam. They'll reimburse you some of the cost. I can't speak for all programs, especially some of the smaller programs will, because it's good for their marketing and their recruiting if they can show a high FE exam pass rate. So it's if they can help you out with those costs, some places will do that. Okay. Other questions? Awesome. So, right, we've kind of hit on some of these. What are some advantages? Well, there's opportunity for, because that's more specialized. If you're a licensed PE, there's more specialized work. There's higher responsibility work. That does mean you're also exposed to higher amounts of litigation, being sued. But as long as you're doing your job right, that's you won't get exposed to that. But it is definitely exposure to higher rate of pay and opportunities. You don't have to go hire a licensed PE, or you don't have to work under a licensed PE to supervise PE level work. You can stamp the documents yourself. You can offer an engineering consulting service, right? And again, legally, you can't call your business an engineering service unless you have a licensed PE on staff that is recognized by your state as an engineer. So these are all some advantages to kind of think about. Again, are you going to need a PE in your area that you go to work in? I can't answer that for you. There's too many opportunities for people with an engineering degree to find good gainful employment, and not all of them require PE. Okay? I don't have statistics. I'm not going to try to quote any statistics on, well, this number of engineering graduates will go on to get their PE, but I would be surprised if it's more than 50%, honestly. There's a lot of people with engineering degrees, and there's a lot of work that requires somebody with that generic problem-solving skill set that no other area of training is filling that niche, and so engineering is filling it quite readily. All right, so again, I can't speak a lot of knowledge about the content of the PE exams. From what I've seen, they are more applied and more kind of real world type of problems a lot of times, whereas the FE exams are more kind of base type problems similar to what we find in traditional courses. There's a number of topics covered on the FE exam. It will vary by discipline. You can take a specialized exam, so there's going to be an electrical engineering FE exam, there's going to be a mechanical engineering FE exam, there's a chemical engineering FE, so most of the different fields have their own FE exam specialty, and there's typically offered to you a general option, just kind of a general FE exam that's in kind of the traditional multi-topic vein. And historically, I don't know how they do it now, but historically they would allow you to look at all of the different exams and choose which one you want to take. That eats into your time to take and solve the problems, but you can look through all the other exams normally. I don't know if they still do that, but last I heard that is still the case. So what are the subjects covered in there? Well, here's a list here. We're gonna talk about these, okay? But most of these subjects are typically a 3-hour course taught within an engineering program, okay? Because those are relevant, important topics that are fundamental to engineering. Hence the reason they're on the fundamentals of engineering exam, okay? Now, I need to update this, but I've made these flowcharts available to us through Canvas. I downloaded those here, so I'm gonna open these. Right, so I've built flowcharts over the years for students specifically going to OU and OSU. I've not updated these this year because I've had other things going on. But these are available to you guys, and I need to put these on our website so they're available to anybody. I know this is small. I'm sorry. Trying to get a whole bunch of information on one page there. I can probably zoom in. Well, I can definitely go full screen here. There we go. So this is, so I've got one set of flowcharts here for the programs at OU, University of Oklahoma. I've got one set of flowcharts for OSU, Okay, and those are both available to you on Canvas right now. This would be kind of a suggested flow chart for University of Oklahoma majoring in civil engineering. Okay, and if I move through, notice when I go to another major, notice what changes and what doesn't change. So it's environmental engineering at OU, right? So if I go back, civil, environmental, right? Those are very similar. And I go to another field, chemical engineering. Notice what changes and what doesn't change, right? We go to mechanical engineering, and you know, out at the end, there's sometimes there's a lot of change, sometimes there's not. But notice the first couple of columns. Go through all these. Petroleum's a little different, right? But most of these, there's not much difference. Okay. Now, again, please understand that the last I updated these was over a year ago. I've not gone through. I haven't had a moment to look at all the programs at OU and compare and make sure which ones have changed and which ones have not. So if this is a little out of date, I apologize. What you want to do is you want to go, because this is what you're working towards. You're working towards this bachelor's degree. You take a moment and go look at wherever you think you might want to go to school and what major or majors you want to major in. And you'll find most likely a flow chart, because this is what we've learned in academia. Is one of the easiest ways to describe, because these courses are complex, okay, or at least the order in which you take these courses is complex. Go see if you can find a flow chart for whatever school and whatever major you're interested in, and compare it to what we offer here. And then let's talk, and come talk to me about, okay, did any of these classes not transfer, which ones do transfer, and I'm pretty knowledgeable about that because I've been doing this for a while, okay? I'm happy to answer your questions. So here's the thing, what's probably, it's pretty obvious, the advantage of the flowcharts is it's real obvious that you don't want to take Calc 3 before you get Calc 1 or college algebra and trig done, right? I don't want to jump right into Calc 3 if I don't have trig done. That's pretty obvious, okay? What's not obvious is, should I take strength of materials before statics? No, absolutely not. So sometimes a lot of the courses later on, it's not going to be obvious from the title of the course that this is the order it should be taken, and that's the purpose of the flowcharts, is to say, now you can look all this information up, you can go to the college catalog, read the description of each individual course, see what the prerequisites are, and that'll tell you which order they should be taken in. But this is a lot more efficient. Right? So again, a lot of schools will put out a flowchart like this. This is ours. The way ours works is you take everything in these four columns right here, and you've completed the requirements for our associate's degree in that one of the options. It says this one down here is for the general option. Maybe you would meet the requirements for the mechanical aerospace option. I don't know, probably not, but you'd probably be pretty close. So that's the basic idea. And you don't have to take it exactly in this order, exactly this semester. You can move around. The stuff that does not have an arrow connecting it to something else, you can take it wherever you want to put it. Just get it to where it works in your schedule. But the things that have got arrows, you have to take them in that order. At least you should if you want to pass them and get anything out of the course. Okay. So you want to take Physics 1 before you try to tackle statics. I've seen people do them together in the same semester. It's a terrible idea. You normally end up struggling in both. Don't do it. It's just not worth it. Same thing with statics and strength materials. You should not be taking those together. See people do it on occasion, but it's a really bad idea. So again, these are available to you. If you have questions, stop by and ask. But I do want to show, look what doesn't change. This row right here, you got to get calculus done. You go with any engineering program around the country. We're going to start at calculus 1. You need to have, if you're not ready to start in Calc 1, that's okay. We'll get you ready. Just understand that that's because basically we start engineering courses after Physics 1. And this is calculus-based physics, so we need you to have some basic calculus in place before we can do calculus-based physics. And then we get into courses where we're going to show you how do you apply what you learned in physics to the real world. Okay. So again, engineering is the application of existing scientific and mathematic knowledge to solve practical problems. We've got to make sure you've got good mathematic and scientific knowledge before we can start talking about how do you use that to solve problems. Okay, and that's the reason the course, the curriculum is structured the way it is. Okay?
May I ask another question?
Absolutely.
How would you rate the level of difficulty of like calculus in comparison to the rest of the classes? Like if I accomplish an A in
Mhm.
all three of the calculuses, should I feel confident that I can handle the rest of them, or is level of difficulty harder as you progress?
Well, here's an interesting thing about engineering. Hard work and effort sometimes is just as good, if not better, than sheer intelligence. I've seen people, I did recruiting before this job. I did recruiting at a university for an engineering program. And I saw people with an 18 ACT score finish an engineering degree in 5 years. And I saw people with high 30s ACT score change their major the second semester, right? So if you're properly motivated, that's much more important than just sheer intelligence. As far as difficulty, we will continue to kind of ramp up the difficulty incrementally as you progress through the flowchart. But here, you kind of hit a point. I like to tell students, you hit a point right in here, so the kind of the second semester of your sophomore year, first semester of your junior year, you start hitting courses where it's about as hard as they're going to get. They don't get any easier after that. You just get used to it, all right? And so you're getting there. If you can make an A in calculus, and then you can survive physics, you're getting pretty close to the level. You're not there yet, right? But again, as long as you're willing to put in the effort, you're gonna be fine, most likely. If you can make an A in calculus and you're willing to put in the effort, you're probably gonna be fine. We are gonna ask you, are you willing to put in the effort? That's just, it is what it is. Because what we do is not easy, and what we do can literally kill thousands if we don't do it right. So it's important we do it right. So, other questions? Cool. So let's talk about some of these subjects here. So these, again, why all these subjects? I've got a list here, and we're going to talk about these. Well, that's, again, engineering is the application of existing mathematical and scientific knowledge to solve problems. The FE exam is going to test you on your ability to, your knowledge, your mathematical and scientific knowledge, and as well as give you kind of a basic test on how well you are prepared to apply that. Okay, and again, it's similar to the problems that you encounter in, say, a thermodynamics or a dynamics course. So let's talk about some of these subjects. So mathematics, everything from basic algebra all the way up to an application of geometry. There are some calculus and some differential equation problems on the FE exam. I remember they were far fewer, and it's been a while since I've taken it. I don't know. I assume the structure is very similar. I do remember that the calculus and diff E problems seemed fewer and far between than just the basic algebra problems. Just given this information, can you find a solution? It's probably just some basic algebra. Okay. So by the time you've survived calculus and you've seen really the inside and out of how algebra is used and how algebra actually works, that's a lot easier to apply the really critical basic knowledge that we've got to be able to do all the time. And if we need to apply the more advanced knowledge, we can. Statics and dynamics. These are often two separate subjects. Almost all engineers will take a course called statics. Statics is it's basically kind of it's an extension of physics. It's the idea that if I've got a body that what we call a rigid body, that's something that does not deform, okay? It doesn't change shape. So statics is the application of forces to a rigid body, and that does not accelerate, doesn't change its motion over a period of time. So, if I apply a force to this table here, right, and the table doesn't move, so I'm applying a force to it and it's not moving and it's not rotating, there are other forces required to prevent motion of this table, right? If I'm just out in space and I'm anchored to a space station, and this table's just floating out in space, and I give it a shove, it's going to move, it's probably going to rotate, because there's no other forces preventing that motion. Here, there's forces preventing that motion. Statics is the study, the advanced study of what's required to keep that table from moving and rotating. Because that's really important when we start looking at buildings. Right? It is what keeps this building from moving and rotating, what keeps this bridge from moving, and especially when you get into like a truss or something like that where you've got multiple components. How do we break down a multi-component structure into individual components and look at the forces required to keep that structure from deforming and keep the structure itself from moving? And then dynamics is kind of advanced physics for us. It's the application of it's the study of application of forces to rigid bodies that do accelerate. So beyond just your basic physics class, we also start talking about what happens when those bodies also start really rotating. How do you describe this motion when the XY axis no longer makes sense because this thing is, where is the XY axis? Well, if the XY axis is constantly rotating, how do you measure that, right? That's dynamics, okay? And again, that's focused on bodies that don't deform. And typically we'll have a course called Strength of Materials or Mechanics of Materials, where that's basically statics with deformation, right? So as you apply forces, that object's going to deform. It's going to flex a little bit. How much flexure are we looking at, and how much does it change, right? If you're going to OU for petroleum engineering, they do a couple of things different. Come talk to me, and I can kind of give you some ideas. They have traditionally offered a combination course for statics and dynamics. Almost everywhere else offers it 2 separate courses. So anyway, if that's you, come talk. We'll figure out how we can get you going. A couple other fundamental engineering courses, thermodynamics. We'll spend a day talking about engines and energy and basically the basics of thermodynamics. That's probably going to be one of our next lectures. So we don't have to talk too much about that right now. Electricity, electrical science. Most engineering fields require some basic circuitry class. Other fields, obviously electrical engineers require much more than that. But electrical science is sometimes called Circuits 1. It's just a basic analysis of simple electrical circuits. Electronics are not going away, obviously, right? And engineers need to be comfortable understanding voltage and current and how that translates into power and what that means in a circuit, at least on a basic level. And that's, it's an applied course in basic circuit analysis. Some other subjects that normally show up, there's normally a fluid mechanics component. Fluid mechanics is basically, what I tell my students, it's essentially a physics 1 applied to fluids. Right? So everything that we talk about and look at in a physics 1 course, we look at how does those same laws of physics apply to fluids, but fluids behave differently than a single particle, because I've got now a collection of particles. So how does that translate? Looking at, there's normally an economics portion, looking at cash flows, looking at investment, nothing real in depth, but because we're not allergic to calculus, by the time you get to that point, we can talk about money is a function of time, essentially, in our society, and how does that, by the time you survive calculus, you're really good at describing how things change, how a function changes over an independent variable, and so we can analyze money the same way. And then ethics, there's normally some ethics components asking about what's generally considered right or wrong in a particular society. Okay? And so most engineering programs will have somewhere within their curriculum, well, there's a requirement to have somewhere within their curriculum some sort of ethics. I need to add in here sustainability. Sustainability is a new area that ABET is beginning to require in the curriculum for an engineering program somewhere. Okay. All right, so that is the basics of what is a PE, how does one get there. Again, this is where you guys are at this point. Well, you're not there yet, but this is what you're working towards. Okay? And then this comes later in life if needed. One thing I'll mention, they've changed recently. You can actually go now and take the PE exam early The states will allow you to go take the PE exam early if you think you're prepared, and then once you've completed the appropriate amount of experience, then you automatically become a PE. That is now an option. One of my former students that I normally try to come talk to us, he's actually in that boat. He'd just taken the PE recently. I don't think he'd gotten his results back, but he had not achieved the appropriate experience yet. But he had applied, and the board said yes, you can do that now. Okay. Questions, comments, complaints? All right, guys. So moving forward, that's kind of how class will work. Is I normally won't go the entire hour and 15 minutes. I'll go around an hour, somewhere between 45 minutes and an hour. So you will have most likely a few minutes at the end of class that you can ask questions about your computer, your Excel assignments. Okay. So what I would suggest is try to come with targeted questions, right? Don't plan to get a lot of work done here necessarily on those assignments. Try to have worked on them and okay, how do I get this formula in this cell to work? Or how do I get I've got the macro to do this, how can I get it to do this one other step? If you can bring your targeted questions, that'll be efficient, but the time is yours, you can use as you like. Okay? And if you don't have anything else you need to work on, if you got everything turned in, you want to get out of here, go eat lunch, that's all cool with me. Right? That's what I have. Let me take roll real quick. Let me stop the video because the world doesn't need to see that. Thanks, guys.